Hi there, and welcome to the quick review of Module 6. So what we have in Module 6, we had the data flow testing and we also looked at the metric. So what's data flow testing? In data flow testing, what we have is a structural form of testing, and our point of interest is going to be variables receiving values, and then those values are used. So they are used at a certain point, they're defined at a certain point. It actually provides and serves as a reality check on path testing. So what are the anomalies that we look at? Typically, the anomalies that we look at would be around the DUK. Variable is used but not defined. Variable is defined twice, or variable is defined but never used. And this is one of the techniques which allows us to do some amount of static analysis based testing as well. So you actually don't need to execute code. You find faults in the code without executing it. This could be done by tools, or this could be actually done by dry running the code. So for DU testing, we are looking at a graph, single entry, single exit, and between this, whatever is supposed to happen, you're going to have somewhere a variable is defined and another place it is used. So what do? We have got concept is use the DU pair. A definition would be assigns a value, and a use would be uses or references a value. Like we have got v is equal to x plus 4 is a definition of v, and here you would find v is equal to v plus 1 is also a use and also a definition. Thus input of v would be definition, print of v, if v is greater than 0 or z is equal to v plus 1, where you find use of v in all cases. So what are the steps that we follow? We identify all the data flows, the DU pairs, and then we design test cases for the inputs to that particular function such that the DU pair will get executed. There is a path along the way where that particular variable will be exercised in the form of definition and use. That forms the test case. So this indeed is a very demanding technique, but wherever there are high reliability requirements, data flow can be very, very useful. And it has capability of detecting very good defects. Changing paths or changing tracks. What we have is learning a metric, which is the Miller's metric for all the code-based testing. And why do we learn this particular metric? Because we want to measure, we want to understand, we want to control, and further we would like to improve. And that is where code-based testing metrics comes into play. And Miller's test coverage metrics are of these many types, where he looks at every statement, every DD path, every predicate to each outcome, C1 coverage plus loop coverage, and you would see how the metric is denoted, which is given over here in this particular column. You've got multiple condition coverage. In fact, every program path that contains up to k repetitions of a loop. C stat, statistically significant fraction of paths, and well, all possible execution paths. This metric would be useful in various occasions when you're looking at D2D, that is, say, decision to decision, or in fact even looking at statistically significant fraction of paths. Project to project, program to program, you would have a different focus. These are the coverage metrics, and we looked at some of the key metrics even when we did the path testing. Thus, now you have all these tools with you for code-based testing to take you forward. So that concludes our quick review for Module 6. Thank you.